of our previous meeting session that got deleted, pretty unfortunately. So I will be using REPL this time, so the presentation will not really make an appearance, but it might pop up a few times. Depends on how relevant it will be. But the content is relatively the same, less factory analogy though, because I know that was quite confusing in a lot of topics. So, for now, if you go on REPL.it, which is a pretty cool piece of software, I don't think that's there in the boiler template, and you create a new REPL, so it's replit.com, and it'll be in the YouTube description, alongside the tools needed to download for WebPilot. So make sure you check those out as well, because that's what we'll be using to program our robot in the later lessons. So please download both of them. I mean, you don't have to download repl.it, you just have to make an account, but for the other one you do. So replit.com is just important because we're going to be using it for our essentially just learning about Java. So there will be professional tutorials linked in later as well, especially in our classroom and our Discord. I'll also link them in the description later on. You know, they're done by actual professionals, not me. So they might be a little bit easier to understand. I'll still try my best to sort of release these Java tutorials. They won't be actual lectures, but they'll be recorded by myself. I know that you take a break from your screen. Thank you for protecting my eyes, man. I appreciate it. But yeah, so I will just be doing it like that. And so let's get started. So Java is a decently complicated language, especially at the start. It's not very easy to understand, especially because of these special names over here and this very intimidating line over here. You don't have to really understand that, but when you first make your project, it'll look something like this. Maybe the indentation will be a little bit weird. To change that, head over to your settings. You can also change the theme, the font size, and everything else that's relevant here. And so, yeah, it'll look something like this. So we're not really going to do that right now. You could run the file over here, but just to show you guys exactly how it works, and kind of bring proof to my statement of, this is, your code is more like a blueprint, and it's sort of planning out exactly what's going to be happening, or what your code is going to look like at the end. And then what's building your code is something that's called a compiler. So Java actually comes with its own compiler, but there are other compilers such as Gradle, which use different tools to sort of incorporate it better and build larger projects. So Gradle is for like big professional projects, but we have Java compiler too, which works perfectly fine. And so Gradle itself is what we use for a robot, but I'll just teach you guys how to use Java C because Gradle has shortcuts, which makes life a lot easier. So Java C basically is like Java compile, and so we're going to do Java C, and we need to write down the name of our file. So main.java. This is just exactly how to run the file over here without using this run button. And so it's going to compile our file and turn it into a class. And you'll notice a correlation here, class main and main.class. And so class is what Java calls the executables. It's basically just a template or a design for an object that the builder will create. And the builder is our compiler. So this is the object that our compiler created. It looks pretty hard to read, most of it filled with question marks, sort of legible. But this is sort of the object that is created. And so with this object, Java will then actually host it and run it within itself. So to run the file, we just have to do main. You don't have to add the .class. It'll just add the .class itself. So you just have to write the name of the file. So we know that we want to run main, and no C this time, it's just Java. And so this will run the code, and it will print out hello world, which is the point of this tidbit of code. So let's understand exactly what's happening. Not in too much detail though, hopefully. So class main over here is our good friend. And so class main, like I explained, it's the name of the object or the template that Java will be creating based on our blueprint. And then after that, we have our main function over here. So we aren't really going to worry about this yet, but it's basically just a few delimiters to specify that, oh, this is going to be the main function of our code, and it's what Java should automatically run. So when our object is created, this will automatically be run by the builder. The builder will be like, oh, I don't need to do any of this useless stuff. I just need to do this one thing, and I'll do it. String args over here is a little bit confusing. So string is actually a type of template as well. It's a type of object, but we haven't really gotten into it, so don't worry about it. It's whatever. And then this is specifying that it's an array and args. So this is pretty alien, but all it's saying is if I were to run my command over here and I added some words here, then these some words here would go right here into this array of arguments. So these are called arguments. If you've ever worked with command line before, then you'll notice that they are arguments that you have in command line, but there are also arguments over here. So these are just basic sort of, oh, this is exactly what I'm supposed to be doing. These are the arguments that I want to kind of add in just to influence the code. We're not really going to be working with that, but it is relevant in our code. So this over here is our print function, and basically system is a part of our Java machine. So it's basically, this is generating an object that's going to be used in our Java machine, and so system is a part of that machine. And so within the system there's our console, which is what this print stream out is. So this is the console if you see in REPL. And so this console we're going to be manipulating. So we're going to go to the system and we're going to tell the system, okay, so I know you have these objects already. I want to access one of these objects. Can you give me access to the println function? And it's going to be like, yeah, sure, I got you. I'll give you access to it. So you just have to specify where it is. So we know that it's in the system part of our Java machine, and we know that it's in the out, in the section out of that machine, and we know that the function is called println. And so we're going to do that. And so what exactly is it printing? These double quotes. This is actually a string. So before we get into strings, I should understand, or I should help you guys understand what makes up a string. And so that's kind of like the building blocks of Java. So Java objects are like, let's say, Lego mechanic structures, but we need to know about the original Legos before we get there. So all Java objects are made up of these few variables, and they're called primitives because they're the building blocks of all the other objects, more complicated stuff we see later in Java. And so the first building block is the Boolean, and so Booleans can only be true or false. So a good example is like a game over within a game. So what we can do is we can keep looping the game, or we can keep running the game until game over is true. So we can, a Boolean can only be 1 or 0, 1 or 0, and it's one binary bit, which makes it the smallest building block of our entire arsenal, which is really cool. And then second smallest is a special little guy called the character, or the char. I don't know why people pronounce it differently, but it is. And so the char is used to hold one single letter. So if you wanted to hold, let's just say, let's just say a letter, then we can hold any letter. But the key point is you can only use single quotes for these. So let's say we put a V over here, then that's our letter V. So that's one character. So chars can actually go up to 8 binary bits, I think. It's from 0 to 255, so it's ASCII encoded, which is just a special way of deciphering text, or turning numbers into characters. And so a better way to sort of not really look at it, but a better way to sort of understand it is it's a box filled with numbers, but the computer understands it in a special way that turns it into a letter. And that special way is called the encoding. And so the most popular form of encoding is ASCII, just for programming right now. So that's pretty good. So that's our single character. Again, only one character. You can't have multiple. Like I can't type my name, or else it becomes an error. Only one single letter, one single character. And this is 8 binary bits. So 8 ones or zeros. Next biggest one is our integer and our float. So an integer is any real number within 32 binary bits. So it can only reach about, I think, 2.3 million. So if your number is about 2.3 million or less, then you can stick with using an int or an integer. So an integer can be negative or positive up to that limit. So we'll call this, so integers are really helpful for any sort of math operation. So, you know, if you're in math and like x equals 3 or something, then you can sort of assign it like that. It's any real number. But if I wanted to set it to pi, like 3.14, that's going to set an error because this is an integer and we're trying to store a float value to it, which isn't possible. It didn't give me an error, but that's just because REPL.it is having a stroke. But speaking of real numbers, we can actually store real numbers like this. So let's say we want to store pi, very simply, 3.14. Floats are also 32 binary bits. So this one is 32 ones or zeros, and this one is also 32 ones or zeros. But floats can't store as much bigger numbers, but they can store decimals as a trade-off, which is great news for us. And then the largest building blocks are longs. So longs are basically integers, but much, much larger. So they're 64 binary bits, which means they can go exponentially larger. And so the size of it is always 2 to the power of number of bits minus 1 minus 1. And so the reason why the formula is so complicated is because this minus 1 is to get rid of 0, right? Because we're going from 0 to whatever number, so we have to account for 0. And number of bits over here is essentially the number of And the reason why we're taking away 1 from the number of bits, is the number of bits, self-explanatory, is because we need to account for the fact that there are more numbers in the negative side. So we need to take exactly half of the numbers, which is the exponent minus 1, for the negative numbers, and the other half for the positive numbers. So we need to split them in half to account for both. That's sort of there. So longs are much larger because they are 64 binary bits. So we can set this to like a huge value like this, and it's perfectly fine, I think. Maybe not so perfectly fine. Oh no, yeah, it's trying to assign it to an int, which is so weird. REPL is just having a moment here. Whatever, it's a big enough number. And then we have our double, which is the same thing as a float, but again with 64 bits, which means it can store higher numbers. So we'll call this pi except you can't have stashes, that's pi. And we can call this like 3.141596 blah 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 blah. Right? And so yeah, these are just the building blocks of all Java objects. They're the base. And that's why they're in lowercase. That's what makes them special. And that's also why they're blue. Because they're the original, they're the building blocks, and these are only made up of binary. There's nothing special behind them, only binary. And then once we're done with this, we move on to complicated objects. So let's say that we wanted a group of chars together to form a message, or a name, or a string of characters, and that's exactly what it is, so a string. And so objects always start with capitals, which is the difference, and you should always, whenever you make your own objects, start them with capitals. So we can call this the name, right? And so this name can be built up of multiple strings, but we use double quotes here. And the double quotes are to signify that this is indeed an object of the type string, and it isn't one single character. Another way you can do it, I think this works, but I don't know for sure if Java really accepts it. I'll have to double check this. Is if I add each individual character like this, then I can also form my name, because it is just a group of characters mixed together. So this isn't just built on binary. It has a lot of unique features that we can use. It has a lot of functions within itself that we can use to sort of play to our advantage. And so let's get back our print function. We don't need these guys anymore. I mean, I'll keep them up. Actually, for your reference, I'll keep them up. So let's get back our print function. So system.out.println, and let's print our name. Right? And so println, again, it prints it out, and the ln stands for it adds a line at the end. So we're printing out our name. And so we want to do that through here, java c main.java, and then we'll just do java main. Oh, I can't spell. Oh, we have an error. Float pi equals 3.14, and we have an error here. I think it's because I named this pi. Okay, no, we don't want to name that pi error. Let's try this again. I think it's because pi is already taken in Java, and so it just confuses things. Oh, no, it's still wrong. Lossy conversion from double to float. That is so weird. Okay. Hold on. I'd like to let you guys know that that actually works normally. I don't know why it doesn't work here. Maybe it's having a moment. Okay. Let's go. And so we're going to run our Java code, and we see my name printed out, right? Pretty cool. But these functions, or these objects, have multiple workers on the inside that can do a lot of other helpful things. So one of them is a function that's called toUpperCase. And so to call any worker within an object, right? So to call anything within an object, so any property of an object, we use dot. And the reason why we use dot is to sort of give a hierarchy, right? So we know that we have one big object, which is the string. And we know that within the string, there's one function called .toUpperCase. So we need to find a way to call this toUpperCase from the string. One way we could do it is by doing that, adding the letter, but that takes a lot of space. So we typically just do string.toUpperCase. And that brings me to my other point. Why don't we just do string.toUpperCase? Well, we need to find our exact object, right? So the object template is called string, so that's kind of like the type of object, but the exact object is called name, because that's an object built on the template that builder built using the template called string. And so one is a template and one is the result of the template. Sort of like one is a design and one is the actual finished product. So string is the design and name is the finished product. So whenever we do any dot functions or anything relating to the object, we're going to do dot. And so let's do name dot to uppercase. I think I killed IntelliSense, so it's gonna be a fun journey, I guess. Okay, so now that we have dot to uppercase, it's going to be a nice little function that's going to help us get uppercase characters. So it's going to print out my name in uppercase. So let's try that. Oh, I think I killed REPL. Oh no, REPL, stay with me. And it's gone. Okay, I just reloaded it, and we'll see how it works. Okay, there we go. Let's try this again. So I'm just going to write out to uppercase again over here, and we'll do java c main.java. So we want to compile the code, right? And then after we compile it, it's going to plan everything out, and our main file should be updated too. There you go. See, now it's a lot more different because we're changing a few things up. That's kind of what we're doing. And so once you've compiled it, we want to run it. So java main, and we'll see that it prints out my name in all uppercase, which is really cool. And so these sort of functions prove that it's different because it's not just binary. There's so much more on the inside that it does work with. And so that's kind of the difference between a primitive, which is a building block, and an object, which is not a building block, but a collection of building blocks and workers.